Good morning dear students. Today we are going to discuss exercise 1.3. Question number 1. Write the following in decimal form and say what kind of decimal expansion each has. The first one 36 upon 100. Here I have to find out the decimal expansion as well as I have to tell that which kind it is. So write 36 upon 100. This is very simple. No need of divide this one. We can directly write 0.36 because the denominator two zeros are there. That's why I have to count two digits from the last and keep the point, that is 0.36. This is what? Terminating decimal expansion. We already discussed what is terminating, what is non-terminating but recurring, what is non-terminating, non-recurring. Everything we discussed in a previous exercise. So this is terminating decimal expansion. Okay. Then go for the next one, that is 1 upon 11. See, here I have to divide this one, 1 upon 11. This cannot be divided, so include 0 here. That's why I have to keep 1 point, that is 0 point. Then 10 is also not divided by 11, that's why include one more 0. So I have to keep it 1 0 in the quotient place. Then how many times it will go? 9 times 99. Again 1 is the remainder. Again I have to include 1 0. It is not possible, so include one more 0. That's why I have to keep 0. Again 9 times it will go 99. So again the remainder is 1. The remainder is 1 is again and again repeating. That's why we can see this one. See 0.0909, that we can write it. It will never end up. Okay. So the particular number 09, a set of number is repeating in the quotient place. That's why this is non-terminating but recurring. Why I am telling it is non-terminating? Because the remainder is what? 1. It will never end up. Again when you are putting 0, again it will go like this. The remainder comes 1. That's why they never end up. So that we can write this one 0.09 bar. See, bar is there, that's why we can tell that this is non-terminating but recurring. A set of number, that is 09 is repeated in the quotient place. That's why we can write this one non-terminating but recurring pattern. Non-terminating but recurring decimal expansion. They asked you what is the pattern, what is the kind. That's why I have written. Option number 3, that is 4 1 upon 8. See, I am going to find out the decimal expansion for 1 upon 8 first. Then I will include 4. 1 upon 8. See, can you divide 1 by 8? No. Keep 0. 0 point in a quotient place. How many times it will go? Only one time. 8. What is the remainder? 2. So 20. So how many times it will go? 2 times. This is what? 16. 4 will be the remainder. So 40. So how many times it will go? 5 times. 40. So the remainder is what? 0. After a few steps of division, the remainder comes 0. That's why it is what? Terminating decimal expansion. So write it here. This is terminating decimal expansion. Okay. So I have to write that exactly what it is. 4 plus 1 upon 8. See, 4 plus 1 upon 8. What is the 1 upon 8 decimal expansion you got? That is 0.125. It will give you 4.125. That is what? Terminating decimal expansion. 3 by 13. Fourth one 3 by 13. So divide it 3 upon 13. So it cannot be divisible. So 0. Put 0 here. 0 point. So how many times it will go? 2 times. That is 26. 4 is remainder. So 40. How many times it will go? 3 times. 39. 1 is remaining. So okay. It cannot divide with 13. So include one more 0. That's why I have to keep 0 here. Because 2 zeros added at a time. That's why keep a 0 here. Next, so how many times it will go? 7 times. 7 3 is 21, 2 is remaining, so 91. So what is the remainder now? 9. 90. 6 times it will go. This is 18, 1 is remainder, so 78. So what is remainder now? 12. Include 0. So how many times it will go? 9 times. 117. What is the remainder? 3. So a remainder is 3 now. So the same number is repeated. That's why we can tell that same step of division will be repeated again when you keep the 0 here. So that we can tell this one is non-terminating but recurring. Non-terminating but recurring decimal expansion. Why? Because bar is there. That's why it is non-terminating but recurring. Fifth one, 2 upon 11. So divided 2 upon 11, it is not possible. So I include 0 here. So keep 0 point. Only one time it will go. So 11. What is the remainder? 9. So again include 0 here. So how many times it will go? 8 times. 88. What is the remainder? 2. So 20. How many times? See, it is repeated. That's why I can write it. You can keep the bar here. So we can tell this is non-terminating but recurring. Why I am telling it is recurring? Because this is 1/8 bar. That's why it is non-terminating but recurring. Decimal expansion. Okay. So we can write this one 329 upon 4 into 100. So first I am going to find out the decimal expansion for 329 upon 4. Then later I can put the point. So let's start. 329 divided by 4. So how many times it will go? 8 times 32. So 9 is there. And 9 how many times it will go? See, 2 times. 1 is the remainder. So again I have to keep point 0. So keep the point here. How many times it will go? 2 times. 8. Remainder is 2. So 20. 5 times. So I will get 20 here. Remainder is 0. So for 329 upon 4 you will get the decimal expansion 82.25. But what I need, this form I got, then upon 100 is there. So we can write 82.25 upon 100 because this decimal expansion I have, that is 82.25. Then upon 100 is there, that's why I have to divide by 100. Divided, it is very simple. Downside, that is in a denominator 2 zeros are there, that's why I have to keep the 2 decimal places here also. Already 2 decimal places given there. Move 2 more points. 1, 2. Then you will get 0 point. Okay. 2 decimal points were already there. I have to move 2 more points. So 1, 2, then keep point. This is which pattern? Terminating decimal expansion. So write it here. 329 upon 400 is terminating decimal expansion. Thank you.